So the first device was invented way back at the 1st century by the famous mathematician and engineer called Hero of Alexandria. The device named Alapal, and it actually was a toy at the museum to amaze visitors. How it works is to create steam inside a closed vessel. By using tube, the steam goes to a ball with opposing exit valve. Thus, the escaping steam creates an equal and opposite force causing the ball to spin. In 1698, the first practical steam engine was invented by two engineers, Thomas Savery and Thomas Newcomen. And the purpose of this invention is to pump out water from a coal mine, and this water will be distributed to the large building. Water is boiled continuously to produce steam. During the piston output stroke, this low pressure steam is emitted to the cylinder. The pressure is insufficient to lift the piston on its own. The weight of the pump rod does most of the work. The steam valve is closed and the water jet is briefly turned on, cooling the steam in the cylinder. The cool steam contracts, sucking the piston downward. At the end of the stroke, the cooling water is drained from the cylinder by an extra passage. The pump fills the cooling reservoir. Unfortunately, this invention has many limitations, and one of them is it does not have gearing to convert reciprocal motion to circular machine driving motion. Nuclear engine was extremely inefficient because it required a lot of energy for the engine cylinder to heat and cool repeatedly. It also caused a lot of thermal stress. Plus, the energy used such as wind, water wheel is very limited and not consistent. In 1736, University of Glasgow has assigned James Watt to modify the nuclear engine so that it will be much more practical to drive machinery. This led to the invention of flyable governor, which is an automatic control system that is used to control the speed of the steam engine. The device will expand as the engine went faster, while the centrifugal force caused the heavy metal balls to spread out. As it spread out, it will control the movement of the steam into the cylinder. In order to decrease the speed, close the steam valve, which can decrease the speed of the engine. In 1780, this engine pattern only used for pumping out water from coal mines. It also used for farming, trade, and many other areas. In 1800, there is 1,500 steam engines worked at Britain, Europe, and United States. This revolution has made Britain the first nation to become industrialized.
So, this is a porta modern steam pioneered by Ignatius Livio Dante Porto, a mechanical engineer who moved the technology of the steam locomotive. So, this is a comparison of the old firebox and the new firebox in the steam engine. So, the difference is it shows improvement by having a primary combustion air which is decreased to 30%, and the secondary combustion air also increased to 70%. And also the second point is the steam produces clean air and does not pollute air to the environment. Next, I will explain about the process in the steam power plant. So, to make simple explanation, the fresh feed water is supplied to the boiler. Then, the boiler will will evaporate the water to steam. Then it will transfer to the turbine, and when the pressure is high, it will rotate the turbine's blade. Then it will produce electrical energy. So to summarize this, the steam plays an important role in the steam engine and the power plant in the current technology today. Basically, those steam have the same thermodynamic principle to produce energy. However, they also have different mechanism and operating system. The high compression block is a block that has large displacement like this. Then, in order to complete one cycle, the engine has to equip with the longer connecting rod. Then, based on the top equation, moment equal to force time distance. also known as torque. The displacement D equal to the displacement of this connecting rod. So a high compression block resulting in smooth power delivery to the engine at low RPM. Second point, use a lightweight flywheel. So basically a flywheel is a device that connecting this crankshaft and the clutch. A light flywheel support the rotation of this crankshaft and delivered the torque produced here to the clutch system, and the clutch will transfer the movement to the gearbox. So with the presence of the light flywheel, the power output will be 100% transferred to the clutch. Then no slips occurred. Next, redesign exhaust system plus with thermal wrapper. Redesign exhaust flow, enabling a smooth engine output at different RPM. Means no output of the engine power is wasted. Then insulate the exhaust system with a thermal wrapper to maintain the engine optimum temperature. Means like if the heat produced exceed the optimum temperature of the engine might be broke down or suddenly inefficient. This is the complete picture of exhaust system. This is exhaust manifold, then a pipe, then this silencer, then this the tip, exhaust tip. So this is like old school design, long time ago. Then for the future steam engine, we could make it like this. This is the new design to improve exhaust flow rate, and here, here, and here. So to maintain the engine optimal temperature, one could insulate this these pipes with thermal wrapper. Insulate the manifold with thermal vapor to maintain its optimum temperature. So the last point is cooling system. Here we have two options, liquid cool or air cool. Manufacturer can build a steam engine for future based on its purpose for cooling system. For example, like manufacturer can build a air cooled steam engine for domestic use. Domestic steam engine just use a simple engine, no need to have a bulky engine. Then for heavy industry, manufacturer could build a liquid cooled steam engine to for a long life purposes. For example, like this is air cooled engine. This is the extended fins, as we know, as we learned in our course. This fin is to provide heat exchange from the inside of the engine to the surrounding. So next, various design based on its purposes and displacement. Radiator system. Basically, liquid cool engine have many device and equipment to operate it. For example, like we have cooling fan, we have pump, and we have thermostat. So a large displacement engine prefers liquid cooling system.